Hi, everyone. It's such a privilege and a pleasure to be here. It's so great to see you all while we talk about agents at the application layer. My name's Alex. I work on developer experience and developer education at Mastra. And I'm joined by Tony, who is a founding engineer at Mastra and previously the co-creator of Next.js and the co-founder of Evals. Tony, it's kind of amazing to be doing this with you. I've given some talks, but never co-presenting a talk. Have you done that before?
Not at a conference. We've done some workshops together, though, co-presenting.
Well, that's right, yes. We've done a few Zoom workshops where we teach people about Mastra features, but never in person. So thank you for the opportunity and for sharing this moment with us. We're both here today together because we're building Mastra. Just out of pure interest, has anybody heard of Mastra before today? OK, yeah. Rachel's heard of Mastra. I know you've built some cool things before. That's nice. Mastra is fundamentally an open source TypeScript framework to help you build agents. And it was created by the founding team behind Gatsby, which I suspect some of you might have heard of. You worked at Gatsby as well, didn't you?
I did, yeah, for a couple of years in the very beginning of the company.
How did it come to be that what's the story there? It feels like, so I joined Mastra. I didn't work at Gatsby. But I would say 80% of the engineers who work on Mastra worked at Gatsby. What's the story behind that?
I don't think there's a story per se about that. It's just we enjoyed working together so much that we all came together again.
And I love that everyone building Gatsby was like a framework person building a framework. And Mastra is a framework too, so it feels really relevant. And I didn't quite think about frameworks this way until I joined Mastra. But I realized that frameworks are fundamentally education tools. When you're learning how to build web apps or single-page applications, there's a bunch of concepts, a bunch of new things. The frameworks give you the building blocks, and they tend to go together well. So you can kind of learn the path and figure out how these things go together to build something unique. And that's kind of what Mastra is, but for agents. And so just like you might have something to help you with routing in a front-end application, we'll give you building blocks to help you with agents and giving them tools. We'll give you things like constructs to build workflows. And any of these acronyms you might have heard of, whether you're familiar with them or not, like MCP or A2A, Mastra probably has some kind of primitive to help you with that. And so it helps you build agents more quickly. And if you're newer to the space, you'll find that it helps you get there a bit more smoothly as well, because the building blocks are built around common patterns you'll likely need. And it is because we consider ourselves educators that, aside from only creating the framework, we also published a couple of books to help people with the principles and patterns of building agents. I'm sure you've seen these dotted around, and thank you so much to the organizers for placing them around as well. I just want to assure you that if you haven't taken a copy yet, you're very welcome to do so. You should take both because they complement each other. And if you want to take a few more for your friends or your team, seriously, take as many, fill your backpack. We'd love for you to share the word. And so just out of interest, who here has built an agent already? And who has shipped an agent into production? I'm not seeing many hands, and actually that's a great thing, because it doesn't matter where you are on the agent curve. You're going to learn a little bit today about the possibilities of building agents. And so we're going to talk a little bit about how to build agents with Mastra. We're going to do some live demos. I don't have a complete death wish, so we're not going to do too much live coding, right? But we will run some live demos.
Yeah, we're going to try and run some stuff, and hopefully it still works.
Yeah, we managed to avoid the rain all day, and then coming from the cafe to here, we got absolutely drenched in rain. So hopefully we've been unlucky enough, and our demos actually work. But we want this to have demos and examples, not just a bunch of slides. We will flick through some slides, though, to show you some of the new patterns we've seen that are shaping the future of agents. These are things that we're going to try and relate to the front end, and so you can see how the front end experience might evolve in the coming months and year. And then one thing we've heard a lot, and I think the category of this segment of the conference is about agentic use cases for agents. And so we wanted to look at the spread of what people are building with Mastra, and then show you some examples to hopefully inspire you and connect the dots. And then we're going to finish with a bigger demo from Tony, where we talk about how to connect agents to your front end. And we're also going to look at an interesting idea whereby an agent can call tools on the client side. We don't think that front-end developers are utilizing this enough, and it could lead way to some great experiences. If you have questions, I'm sure you've been briefed already throughout the day, but please don't hesitate to ask them in the app. We'll do some Q&A at the end of the session with the help from Hendrik.
And actually, don't hesitate to put those questions in as early as possible, because we're going to do a QA right after our presentation already regarding our topic. So do put those in if you have any.
That's right. OK, so how to build an agent with Mastra. Shall I attempt to do something live and hopefully it works?
Well, let's give it a shot.
Doing live coding was always a bit risky, like for years now. But when you bring agents into the mix, which have a mind of their own, there's always an element of danger. I thought you might appreciate the last couple of talks of the day having that possibility of something go wrong, even though it'll be devastating for me. And so here's the Mastra website. The best way to get started is to copy the command, npm create Mastra, and then you'll run it like so. This will prompt you to give your agent a name. I'm going to build a weather agent. You can pick a model. The really cool thing about building with Mastra is that it's model agnostic. So whether you want to use an OpenAI model or an Anthropic model, mix and match, maybe change later. Because it's a framework decoupled from the providers, you can do that. I'm going to skip entering my key for the time being. And I'm going to enable Mastra's tooling for agents. When you're using a coding agent, they'll often draw on the data they were trained on. But with frameworks making so many updates, they can often feel a bit out of date. So we've taken a lot of care to build skills that are up to date, that give your coding agent expertise about Mastra. And this way, of course, you can hand-roll your code, but you can also ask your agent, and it will have up-to-date knowledge of the latest features, idiomatic patterns, all that good stuff. And so because this will take just a moment to run, and I don't want to paste my environment keys on screen, I'm going to switch to a weather agent demo I created before. But rest assured, it's exactly the same. There's no smokes and mirrors here. And we'll just take a quick look at the code before I show you a demo. And so with Mastra, you define a Mastra instance, and then you add to that instance objects that represent things in your agent. For example, an agent, but also storage for things like message history. Let's look at the weather agent code quickly, and then I'll show you the weather agent in action. Here we give it a name. Every agent has a model. In this case, we're using 5 mini. But if we were to start typing here, because it's fundamentally a TypeScript framework, you get auto-completion for all the models available. You could even use a model router, like OpenRouter. This is a great way to try different models you might not have experienced before. And then, of course, an agent has a tool, likely many, and a system instruction that guide that model to use the tool to complete an open-ended task. Let's quit out of the code and run a local development server. So what we're doing here is actually running 2 things. The first is a local web server that exposes endpoints for your agents. You would likely connect to these endpoints from your front-end application. It also creates a local studio. So Studio is fundamentally a development tool that helps you test your agents and iterate on them before you're ready to build a front end necessarily. So here's the weather agent. I can ask it about the weather in Helsinki. I think it's raining in Helsinki.
That's what I would expect it to say, yeah.
Let's find out. And there we go. It calls the weather tool like so. You can also switch the model here if you want to. This is a good way to quickly iterate and test different models. You can dial in settings like the temperature and the top P. Together, these control the randomness of the model, so you might get more creative outputs, albeit a little bit less predictable. What should I show next?
Do you want to show tools? Like you can also just test your tools outside of your agents, for example.
Yeah.
There's like a tab that lets you execute it. You see what parameters it takes in. We could also look at workflows. That could be interesting.
That's right. So you can kind of isolate a tool and test it with a specific output. So then you kind of assemble the tool. Once you're happy that's working, you give it to your agent. You're sort of isolating things to build them one piece at a time. So an agent is where you use a model's reasoning capabilities, and it sort of decides what tools to call, when to call them, when it's finished executing, how it wants to respond. This is immensely powerful for certain types of agents, but obviously the more autonomy your agent has, the more the likelihood that something takes a wrong turn or something unpredictable happens. And what we're kind of talking about today is not just how to build a cute demo, but how to build a genuinely useful agent. And there'll be more examples of this throughout the session. Often when companies are building agents, they're a bit off-put by just having a model do all the brain work, all the reasoning, all the deciding. And so it can be more productive to break tasks down into individual steps. A step might call an LLM and do something with a model, something dynamic based on dynamic input and give some dynamic outputs. But the next step might run some traditional, if you like, TypeScript code, and you can mix and match then to maybe just call one agent, but maybe one agent uses one model, the next step uses a different model. This is the basic construct and one construct for building multi-agent systems. And so what we're looking at is more or less the same type of application. This time it's going to stream the activities. It's going to fetch the weather using code, and then as it plans the activities, it's going to stream those to the console.
Although it's not right now, but...
Yeah, well, I think maybe kind of skeptical if I'm looking at the right terminal window, to be honest. But nevertheless, we'll move on. I think then the question becomes, if you have this option to architect and build your agents in different ways, be that an agent or a workflow, how do you decide when to use which?
Yeah, it's a good question. What I typically see is that a user would pick a workflow when they kind of want to pick and choose when to introduce non-determinism into the application. So maybe you have something where, let's say you are processing refund requests from users, and you first look at what is the amount of the refund request. And if it's a very high amount, you probably want a human looking at that. So you're going to short-circuit the AI parts, or maybe do like an AI overview of the situation and their like suggested plan, and then you escalate that to a user. But maybe if it's a small amount, like let's say less than $5 or less than $10, you're just going to go ahead and let the AI resolve the whole thing. So you have these two distinct paths in the workflow where you use deterministic logic to figure out where to go. Or you might have an agent as a step that first determines which path you want to go down. The first, like maybe a smaller model that first figures out what do we actually want to do. Do we want to use the specific agent to resolve it? Do we want to go in like a mixed path or whatever? So that's something that I often see.
Fortunately, the agent did start streaming. I think it was just being a bit stage fright or something.
Should we take a look at what happened there exactly? Because we do fortunately have some observability into what's going on.
That's right. So the nature of the web applications we've built before is that a user would give a fairly specific shape input, like a form, for example, and then it would take a fairly deterministic path through a system, and then it would return some shape that you expect, right? Some JSON object outputs or whatever. But the nature of agents is that you get inputs you might never have anticipated because it's just human language, and you don't really know exactly what output you're going to get when having a conversation with an agent like this. You're not even sure what path it's necessarily going to take, because it might call this tool, it might call that tool, it might loop, right? And so it's really important that you have a way to get an insight into what's going on under the hood. The fundamental construct for this is a trace. A trace you can think of like a receipt for your agent run. It describes everything that happened under the hood. So here we can actually see the call to the LLM under the hood. This JSON object was sent to OpenAI's API. They do the inference, and then they return the response, which Mastra then interprets. You can also dig in and see what happened for a particular tool call. We won't go too much into that. It's just to show that it helps with debugging. And then another idea you might have heard of in the world of agents is this idea of evals and scorers. And what a scorer is, basically, is a function that executes over this trace. This is represented as JSON somewhere. And it looks to see what the output is. It looks to see what happened under the hood. And it can produce a positive or a negative score to give you an idea if the agent is working as you expect. We have a couple of built-in scorers that we've added to the weather agent. So if I click Evaluate Trace and Scoring, you can see that a few of these ran already. I'll just focus on the completeness, or rather the tool called accuracy scorer. What that scorer does is it checks to see, did the weather agent actually call the weather tool? The reason that's an important thing to measure is because suppose I asked about the weather this morning, it would say that it's dry. I could ask the agent, what's the weather? And it might look at its chat history and be like, oh, I already know the answer to that. I'm going to be lazy and not call the tool. But the consequence of that is that we would get wet because it started raining, right? And the more likely use case is you're fetching stale data, or you have stale data, and you want to refresh it coming from a database.
So we've looked at this from the studio, but how would you actually go and call this? Like, how does this work under the hood?
Yeah, that's a good question, because sometimes when I show people Studio, they think, oh, so Mastra helps you build Studio apps. And you can run your agent in Studio. That can be handy for prototypes and internal tools. But fundamentally, what the Mastra server is, remember I said we were running two servers. One is for the development server. sorry, one is for Studio. This is actually a React application, by the way. The other server is the Mastra API. Maybe you can tell us a little bit about how that works. I think it's a Hono server, fundamentally.
Yeah, it's well, actually, there's like multiple adapters that we support, but the default one that you run if you run Mastra dev is a Hono server that we just spin up as a Node.js server backend. These are all the endpoints that you will ever need to either generate or stream calls with agents. There's specific endpoints for voice agents and streaming voice back and forth. There's even APIs for looking at score results or starting new experiments using scores. Like anything that you can do from the studio and beyond is going to be documented here. You can also swap the server adapter from Hono to other solutions, like Express is probably one of the most popular ones aside from Hono that we support today, but there's other ones. I think there's like 5 or 6 different adapters today, if I'm not mistaken. And it's pretty easy to create one. So what you also saw with the storage is, Mastra is built on top of these different adapter interfaces, and everything's interchangeable. So whatever storage solution you use, you can put in Postgres or MySQL, MS SQL, which is used by a few people, at least in production. I think the default is libsql just because it's easier to run locally, but you can always swap it for something else.
It's actually a good point about, it's kind of bizarre that for most things that Mastra has, where there are options, it usually has providers for a lot of those different options, whether it's models or databases or even observability syncs.
Yeah, indeed.
So we wanted to give you that sort of 101 demo to put some concrete code and concrete examples about what a Mastra agent looks like. I think it will set the stage for Tony's more advanced demo in a little bit here. You saw the agent streaming to the console. You saw the results in Studio. That's great for testing, but of course, you'd like to access that in your front end. We'll show you how to consume those APIs. And it's quite unique interaction because you're kind of streaming chunks one at a time. And you want to render something like ChatGPT, right, where every chunk kind of streams in gradually. We can talk a little bit more about that and how tool calls and things work.
Yeah.
We're just going to take a quick moment, since this is the Future Frontend conference, to talk about some new patterns that we think are interesting and we think you might find interesting too. The first is this idea of memory. I think memory fundamentally changes the way we interact with agents. I don't know about you, but when I use my coding agent or I talk to something like ChatGPT or Anthropic's version, I'm always making new threads and getting lost, and I feel like it never really gets to know me. And fundamentally, it's what is known as a context engineering challenge. It is possible for an agent to look at everything that was ever said and remember it, but the longer that goes on for, the more data basically it amasses. It puts that into the context window, and the nature of context windows is that as you start to approach their upper limit, they can start to drift. They get more expensive because you're using more tokens.
Yeah. Let's do a show of hands, actually. How many people here hate compaction in Cloud Code?
Yeah.
Not that many people hate it. I'm surprised, because I really hate it. But the whole point of observational memory is you don't really need it, actually.
So this is a Mastra feature, basically, but it's an interesting innovation in its own right. Rather than go through the code from scratch, I've built a little demo to show you a little bit how it works. And I hope it's instructive to maybe if you know what a context window is, but you're not quite sure what it looks like, this could be helpful. It's also a helpful illustration of something called prompt caching. We'll touch on briefly as well. But what we're simulating here is an agent that plans trips. In this case, it's helping me plan a trip to Tokyo. I'll press start. And what we see on the left is the normal chat interface, like we've all seen. And what we see under the hood is the context window. This is how the message history is represented and then presented to the LLM, something like OpenAI's GPT models, for example. It's rendered kind of tidily here, but we can switch to a JSON view that's even more nitty-gritty, and we see things like the different role and the assistant role, like so. But by and large, this is nothing. This is using about 95 tokens, nothing at all. I'll reply to the agent, and now it asks me when I'm going, what my budget is. I'm just kind of simulating going back and forth. You can see that it decided to call a getWeather tool. And when the getWeather tool returned, what did it return but a fairly decent block of JSON that represents not just the very small amount of data that is the weather, but some more precise data that we didn't actually need in this case. All those tokens are being stored in the context window, and they're using our budget, basically. These are tokens that you pay for. And so we search for flights and hotels. We go a bit deeper. This starts to feel a bit more like a coding agent or a more deep type of agent where it's not just calling one tool per interaction, but in this case, it's calling two. It searches for hotels, right? It comes back with maybe 10 hotels. Eventually, you're going to pick one. So why does it need those other 9 hotels in its memory, using up tokens, and just giving the model more to work through? Generally, the more context in this right-hand side JSON window you give to the model, the more likely it is that something will go awry. Sometimes that's called drift or rot. And as we keep going, you can see that we have this messages threshold in the bottom left. This is an arbitrary number. You can define this in your configuration. 3K is very, very low, by the way, but if it was higher, we'd be here all day going back and forth. And so once it reaches 3K messages, there's a fairly decent chunk of JSON here, but not all of it is relevant anymore, like those 9 hotels we didn't even book. So with Mastra observational memory, there's an ambient agent that's always there, ready to invoke at a moment's notice. And so once the message threshold is passed, the observer runs, and it has this effect of rewriting the message history in a much more concise format. You can see that we went from 3.1K tokens to just 480. And this isn't compaction, right? Because compaction is what happens when you eventually reach the limit. You've already started to drift at that point, potentially, and then it compresses it in a lossy format, essentially. It can lose information during that process that was important. But with observational memory, the way I like to interpret it and think about it is that it's just gone through every message and rewritten it as history in the most compact form possible while preserving the information that's still relevant to future tasks. And so it took some important, it uses these indicators to give the system an idea of how important things are. For example, details about the trip, but maybe something like the cherry blossom season starting. It could be good to keep in mind for trip planning, but it's not essential information. And so the really cool thing about this is that it happens infinitely. Here's another good example where the tool call just failed. That could have returned thousands of tokens, but we don't even care about those because the tool ultimately failed. And as we continue to go back and forth, we go through this cycle of reaching the message limit and the observer kicking in, reaching the limit, the observer kicking in, and we're saving a lot of context this way. And because, crucially, because this is all in the context window, these form the memories of the agent. So if you asked it about dietary preferences, many, many days or weeks or months later, provided it still remembers that the user is a vegetarian, it should tailor the recommendations so it starts to feel quite personal.
There's actually 3 layers to it as well. Like eventually you will have so many observations that your context window will start to grow despite having all these observations. So we also run something called reflections, where you take the previous observations and you condense them even more, because maybe throughout the conversation, the context has changed. Like you're no longer picking which flights you want to take, but you're more planning the specific activities, or maybe even switch to planning another trip, and the facts of the first trip planning are no longer relevant. And the reflections will eventually filter out the things that are no longer relevant to the conversation currently. And then this is all structured in a way as well. Like you can actually see if you're like scrolling up, you can see that the observations are done in order of when they were made in these different cycles. And it's very much on purpose, because when you take, let's say, 3,000 messages and you condense them into 5 observations, we want to keep those observations at the very top of the list, and then we start adding new messages after that, because then we utilize the prompt cache. So you will pay much less for your tokens. And then once we need to make more observations, or once we need to make reflections, those new things will always be added to the very bottom of the observation list. So as to utilize the maximum prompt caching once again.
That's right, and we can illustrate this quickly, where eventually we do run out of space in the observations window. You don't want to use the entire context window for observations. You set another threshold, at which point the reflector Tony is talking about kicks in. And the reason I think this is fascinating is because the way we interact with agents is changing. Like, instead of creating new threads, it should almost feel like you're talking to one assistant. The limitation is basically memory, because it forgets things that are important, and it doesn't feel like a personal interaction. And then we talk about memory in some tools where, like, it has very naive memory, like ChatGPT, for example. It can identify facts, and then it stores them as part of, like, your user profile. And then you as a user have to go into the settings and change those facts or review them periodically. But I think we all want agents that feel more personal and conversational, and this enables that, and I think changes the way we interact with things on the front end. Do you want to talk a little bit about Harness? I know there was some great discussion about it earlier.
Yeah, I don't think we should go too deep into it, but basically, it's very hard to draw the line where like an agent ends and a harness begins. But the way that we think about harnesses is it's a way to wrap your agent with, let's say, like a specific state that may determine which model provider you want to choose. Maybe you want to just switch on the fly. Maybe you have different modes, like a planning mode and then an execution mode, like you would with, like, let's say, Claude Code or any other coding agent. Maybe you could also have something where, like in a specific mode, it's not actually the user that takes in the inputs, but the inputs come from an external system through what we call signals, which we'll talk about in a little bit. But it's really more of this thing that can then like change the configuration of something that's more static, but then dynamically, if that makes any sense.
Well, that's right. And the most quintessential example of a harness is a coding agent harness. And the really big point we wanted to make is that coding agent harnesses are just the beginning. Here's an example from a company called Artifact. They built an electrical engineering design harness, and it enables you to prompt it with human language and generate schematics, which just like non-coders can code, maybe non-electrical engineers can design satellites or something. And that's kind of a cool example, right? But I believe that there's going to be harnesses for things like finance and every other discipline, most likely. And somebody needs to build those. Somebody needs to build the front end for those. We also built our own coding agent using the harness primitive. One thing we're quite proud of at Mastra is like dog fooding our own stuff. And so we built a coding agent similar to Claude Code or Open Code using Mastra. We would love to tell you a bit more about signals, which enable this interaction model whereby you can have multiplayer agents. But I think we're running a little bit low on time, and I would love to prioritize your demo, Tony. So let's skip over this and just go through the use cases quite quickly, and then we'll switch to your computer and do some demos. I totally hear it when people sound a bit cynical about agents. They think they're cute, they think they're interesting, but they don't really see how they're being used in production. And because the nature of this talk is about agentic use cases, I took a moment to go through some use cases I've seen people using in the wild and identify the common patterns between them. By the way, just to give you a really simple overview, Mastra has these templates that give you an idea of fairly simple use cases. It's a good place to start if you'd like to start playing around with agents. We also help a lot of these amazing companies build and ship agents. And what I did is I looked at them and I tried to identify the pattern between them. And I've broken it down into 3 categories, which are customer-facing agents, internal agents, and agent platforms. I'll run through the slides. There's a lot of different logos on the screen, but I'm just going to pick one of each to keep things moving. And so the first type of agent use case is customer-facing B2B type agents. Think of this as an in-app chat assistant that could benefit an application you already use for the work you do. Factorial is a good example. If you've used something like Rippling or Deal or Bamboo HR, these kind of HR systems, they noticed a lot of people copying and pasting things like performance reviews into ChatGPT and then pasting them back. But that's not very privacy conscious to begin with, and it's not a great UX. And so they use Mastra to build an in-app chat assistant. Sanity, which is a content CMS, they built an assistant that helps people draft articles in the CMS, something that a lot of users would copy and paste back and forth between their coding agents. So it keeps users in their app, which is cool. It gives their users a better experience, but then it does things that weren't really possible before, right? So you can ask it to tag a bunch of pages in your CMS or delete a category, and you can prompt all this with natural language, enabling their users to be more productive and use the application some more. And I think a lot of applications could benefit from this. The other example is more B2C type agents. Indeed is a major career platform. They built this career counselor that helps prospective workers match with jobs that could be a good fit and guide them based on their experience, what could be relevant. And this is, sometimes people maybe speculate that there aren't that many agents in production, or they're all like using, all the agents are coding agents that we've all seen. But Indeed, for example, have more than 100,000 monthly users. Another really cool example I like is internal enterprise search, so changing from customer-facing agents to agents you use internally. And let's just use Marsh as an example here. They wanted to enable all of their employees to use AI. And originally, they were using things like ChatGPT, but it was a bit of a compliance nightmare as they would copy and paste things. And ChatGPT did not have domain knowledge about their enterprise databases and internal systems. So they ended up building basically a ChatGPT clone using Mastra, and then creating their own tools for enterprise search, giving it context about their business. And then because of the model router I showed you earlier, where you can switch models, they decided to use, or I suspect that they ended up using an open source model or something that they control the privacy of, which is not something they could have really accomplished when using ChatGPT directly. I could talk a little bit about internal process automation, but I thought I would just show you a quick example of one that I built at Mastra. So every week, I host these workshops with the Mastra team. Tony, you and I have done one. And I love hosting the workshops because it's so much fun to hang out and to teach and engage with people. But I hate writing the titles and the descriptions and doing all the ops side of it, like scheduling things. And so I ended up building this agent that kind of like automates half the job. And it's genuinely saved me a bunch of time. And I just wanted to show you a quick example. I thought, Tony, since you're like here on stage with me, I could rope you into doing a workshop in the next few weeks.
All right.
I'll take it. And so this is the cool thing, right? This has memory using observational memory. So while I've been talking to this agent for the last few months, it's learned about my preferences. Like maybe I want the titles to be matter of fact. I don't like marketing language. It remembers things as simple as who I am. Like when I say me or I, it knows I'm Alex. And I didn't really have to write any custom code for that. Observational memory gave me that for free. So now if I say something like, I want to host a workshop with Tony at the next available slot on Mastra workflows, creates an event page for me. It's going to do, this genuinely saves me so much time. Like the first thing it's going to do is search our CMS Sanity because I only said Tony and it needs Tony's full name. Maybe Tony, you can expand the tool call. Oh, see, it found 2 Tonys in the CMS, but it knows I'm talking about you. And then maybe Tony, you can move it forward for me while I'm over here and just tell it to continue. And then it listed the events in our event platform because it needs to know the dates of upcoming events to schedule one in the next available slots. We host these every Thursday. And then when I tell it to proceed, it calls a sub-agent, a specialized agent called the description writer agent. The thing I've done that I think has saved me the most time, and maybe Tony, you can expand the web fetch tool calls for me. If you can expand the fetch web page tool, perhaps. Can you expand you're thinking, what have I got myself into? Why did I agree to do a workshop with Alex? If you can expand I think it's collapsed inside the sub-agent now, so don't worry. But what this does basically is it goes to the Mastra docs. Our Mastra docs have an llms.txt file, and we've optimized our docs to support Markdown. So when an agent requests docs about one of our features, this is helpful for our scale and our coding agent, but I've kind of utilized it to then get context about our features and generate the whole description for us. And then maybe now, before Tony backs out, I can say, yes, good to create.
You didn't want me writing that part, huh? Because I could have written no.
Yeah, that's right. And now it's going to call the create workshop tool, and it's going to create it inside of 2 places, right? It creates it in our event platform, Luma, and in Sanity. And here it has a bit of human-in-the-loop approval as well, because I might want to review the final details. I'm just going to trust it and say, yes, approved. And then in the work of a moment, we should have an events page. But I think the thing that's not as compelling as possible about this demo is that it's all happening in Studio. This is kind of good for an internal agent. But suppose I wanted to build a front end on top of this and show my users in my app that tool approval and the streaming and stuff. That's something I think we need to talk about. So with all that being said, I thought, Tony, I could pass it over to you to talk for the next 10 minutes or so about streaming in Mastra.
All right. Sounds good. Can we switch over to the other screen?
Oh, excellent.
Thank you very much. So here you see a very simple and relatively beautiful, given that it was created by Claude Code yesterday. Basically a weather app, which it looks very similar to the chat that you see in the studio. I can go ahead and I can ask, what's the weather in Helsinki? And it should give me pretty much the same information that we saw in studio together with Alex before. It also supports tool approval, much like we just saw happen to one of these tools that was publishing a workshop. It knows the information about the weather. Cool. Now this is a little bit different. I can ask it to set some vibes based on the weather. And what it's going to do is it's just going to go ahead and modify the theming of the chat itself. I could also do something like ask about the weather in Dubai, which should be quite a bit warmer and hopefully a lot less rainy than here. It's going to ask for my permission once again to call this tool. A lot warmer indeed, clear skies. So if you ask it to set vibes based on this weather, it's going to be a lot warmer in terms of the theming of the tone of the website colors. And it also renders this nice little box here whenever it does change something on the front end. I could also ask it to...
a React app or something.
It's a Next.js app, a very short, small one. I'm going to show it in a little bit. I could also ask it to plan activities for Helsinki. And what this is actually going to do is it's going to call a workflow. So you can also add workflows or other agents as tools to agents. And in this case, what is going to happen, assuming my internet died, so no, it's not going to happen. Let's try again. And while it's connecting, I'm just going to go and try and save some time and show you the code, and then we can try and go back and see if it works. But basically, it's a very simple Next.js app that instead of using the API that we showed you earlier directly, it uses a Mastra TypeScript client, which basically just wraps most of those APIs with some convenience wrappers, some types, etc. You can just initialize it with providing the base URL, in this case, the URL of the Master Studio. You could also put in some auth information, but it's local, so I'm not going to do any of that stuff. And then at the base of this, it's a quite simple, just CSS, no fancy UI libraries, just a few components where we're going to render messages a little differently based on their roles. So the assistant messages and the user messages render a little differently on the chat here. And then if there's any pending approvals or any suspensions, which we're going to see hopefully in a little bit, it's going to render a little dialog, like where you saw me click approve on a tool call. It just renders that if my application state has a pending approval that I need to handle. And the way that handling works is basically we do client.getAgent, so we get the correct agent handle that we need. We know what is the ID of the thread, and we can send a tool approval for a specific tool call that happened. Say, OK, send tool approval, you can go ahead and keep executing. You could also, of course, send a decline, and then it's actually just not going to do anything except say, like, hey, I actually couldn't have access to that tool. Now, similarly, let's go ahead and try this again. The Wi-Fi is gone again, actually. But I'm going to connect to my phone. No. There we go. Try and plan some activities for Helsinki. And it's going to call a workflow. And this workflow has something which is called human in the loop. So it's a way for you to communicate back from your server to an agent. You could do this in a regular tool as well. In my case, the way I've programmed this workflow or this tool is to ask the user to provide one of two options. So it's going to tell me what the weather forecast is like. And since it's quite rainy, I'm going to ask it to plan indoor activities rather than outdoor activities. I'm going to go ahead and choose that. And we're going to resume the workflow stream. We're going to look at the code in just a little bit. But what it's going to tell the agent is to go ahead and focus on that activity, and it gives me like a little plan here.
Oh, I see. So this is what we saw streaming in the console before, which wasn't that useful. Now on the front end.
On the front end, yeah. And what that looks like is, again, if there is a pending suspension that's coming in from any tool. In this case, I'm just assuming that it's this specific case where it gives you the weather forecast and wants you to choose outdoor or indoor plans. Has a little handler for it, which basically, again, just changes the application state, and then it calls resume stream on the agent, and it passes whatever focus that I chose. The way that it looks like on the backend side is I have this step in my workflow, which is, by the way, the exact same workflow that Alex had, except I added this one step that suspends and asks for more input. As it calls suspend, and this is like the actual metadata that you then pass back to the front end. And the way that the front end knows about all of that is, if you look at where the messages actually come from, there's a little subscribe to thread function that I'm calling here, which basically makes it so that anything that happens in the context of this thread, it gets streamed back. So we have like an open HTTP stream. You get an SSC event every single time something happens. And then we call this little chunk handler here, which basically, if it's a text delta type of event, that means that it's text that the LLM is actually streaming back to the user. So what we do is we modify the application state, and we just keep appending those text chunks into the last active message, the last active assistant message, to be specific. If it's a tool result, then we only really render this little box here if it's like the set vibes tool. So we can see this. Oh, we don't have that, actually. Let's set some vibes. It's going to render this little box here. So this is that specific case. Again, it's a different chunk type. So we see if it has this effect thing in it. If it is, then we know it's the right tool call type.
Tony, we saw earlier when we called tools, they happen on the server. It looks like this tool call is happening on the client, right? And
Indeed.
That's how it can influence the vibes of the background.
Indeed.
I think that's a very illustrative example. What are some other use cases for client-side tools?
Well, I think there's a lot of, like, this is obviously a very toy example, and it's kind of common to see something like this that changes how the website looks based on something that's going on in the world. You could set any tools here. So the way the client-side tools work in the first place is when you click submit or when you hit enter in the chat here, it calls, again, on the weather agent, a send message thing, to which you can first of all say if the agent is idle, it's going to wake it up and actually start doing something. We're not going to have too much time to go into details on why that's the thing here, but you can set any client tools. And with these client tools, you specify what does the tool do, what is the schema that the server should send back to the front end, and it can just do whatever. I think like a lot of use cases that we're going to see in the future are for things like, imagine your Siri being able to do more specific actions in your apps. If you register something as a client-side tool, now Siri, through, let's say, ChatGPT or something, could go ahead and add a calendar event into like your fantastical calendar or whatever. Or let's say you have like a spreadsheet app or something, and you kind of want to like see it like propose certain formulas or whatever. You could like see it happening in real time in your browser, and you could like accept, decline. You could always go back and forth. You could always, of course, do those kinds of things on the back end as well. But then the downside is you don't really see what's going on, right? And this way you get to be in charge still. You get to see what's actually going on. You can always go back. You can see it rewind. So I think there's a lot of use cases like that. And that's it for...
I think that's perfect timing, because I think we're at the halfway mark. Tony, thank you so much for doing this with me. This was a ton of fun, and thank you so much, everybody, for taking the time to listen.
Thank you so much, Tony and Alex. We have a couple of minutes for questions. So would you guys like to come sit down? And we got a ton of questions, actually, from the audience. Okay. So let me ask the first question with the most votes. Why do I even need to build an agent? If I want to know the weather forecast, I just open my weather app. What are the actual use cases?
That's a valid question. I think we're all a bit sick of the weather agent demo at this point. To give you some context, it's something people often draw on because you want some dynamic data, you want an API, and the weather API endpoints are all open and free. But we'll be the first to admit it's not the most compelling demo. I hope that some of the other demos are a bit more compelling, whereby obviously calling one tool at a time, not so great. But when the agent can decide and choose from a platter of different tools to accomplish an open-ended task, that's a very powerful thing, be that a coding agent like you've likely used, or perhaps something custom you build, as I've demonstrated today.
Cool. Thanks. Good answer. Next question is, besides compacting context and observational memory, are there other ways to deal with the limits of context? How much or little context do you need for anything useful?
Well, that's a very complex question, and I think the answer depends so much on what you're trying to do, right? I think in general, though, the rule of thumb, in my opinion, is that the context should be as small as it can be to accomplish what you need to accomplish, because the larger it grows, the more the agent starts to forget important details. And it doesn't matter how many times in your instructions you say, this thing is very important, don't ignore it, it's going to start ignoring it at some point. Gotcha. If your context grows very large. And it doesn't matter how many times you say it in the chat, it's still going to forget anyway. So you definitely don't want to bloat it with everything. Like now that the context windows are getting so large, this is something that people really start to run into in production. Yeah. But then what that small looks like, that depends so much on your application. Like, and there's other ways, of course, that you can go about reducing it. Like, RAG is one thing. Like you can build a knowledge base where your agent is then able to go and look up things as it needs it. But sometimes it's not very effective. So it, again, depends.
Sure. Thanks. We have another one from the audience. How do you handle security and customer-facing AI agents? Since they may have a broad privileges, they appear vulnerable to the same kinds of manipulation that make social engineering attacks effective.
Yeah, absolutely. I think there's two big things that everyone should be doing if you're doing anything customer-facing. One is make smaller and more specific agents, because the surface area is then smaller than if you have like this one agent that has literally every capability that you could imagine. maybe actually three things, because then the third is workflows are actually quite useful for this sort of a thing, where you can introduce a level of determinism or humans in the loop for more critical things. You should probably do it. Where it's not possible, depending on your application, you definitely want to look at guardrails as well, where you can really set certain rules for what the agent can and cannot do and under what circumstances.
Great. And then someone asked, how far can Mastra take me until I need a subscription?
Well, I don't think you really ever necessarily need a subscription.
Okay.
Mastra, it's all open source. It's all free. You can go on GitHub. It's MIT licensed, I believe, or some very open license. And you can host anything yourself in any way you want to. We have several deployer types, so you can host Mastra on Vercel or AWS, Google Cloud, Cloudflare, what have you. There's a lot of built-in supported platforms. So if you want to host it, you can host it anywhere you want to. You don't need to use our cloud platform if you don't want to. The idea is that it should be so good that everyone wants to use it, right? But we don't ever want to charge anyone just for using Mastra. That's not the game plan.
Okay.
People were asking me just a few months ago, like, how do you guys make money? And they were really shocked when I said we don't. But in the last few months, we've started to build out a platform to help you operate the agents. But it doesn't, like, you don't need it to get started at all. Mastra, the open source repo, has 25K stars on GitHub. It's a really popular open source project, and there's absolutely no need to pay Mastra anything to enjoy it.
You do need subscriptions for other things, like you need an LLM subscription most likely to operate unless you use an open source model, or you might need a subscription for wherever you want to host it yourself. So there are some limitations, but you don't need to pay Mastra anything unless you find value in doing so.
And maybe that was the question. Maybe the question was, do you need a paid model subscription or something?
You could use an open source model and connect it, run it locally, or you could use like a free Gemini version or whatever. Like all the models that are out there, you can use all of them basically. Anything that supports, like let's say like a Llama index standard or something. Anything that you can use with, let's say the Vercel AI SDK, that's going to work in Mastra as well, for example. So.
Great. Final question. What's your take on OpenClaw?
I personally admire OpenClaw a lot. We're TypeScript people, and OpenClaw is basically the most successful open source project in history, the fastest growing project, and it's built in TypeScript, that makes me really proud for one thing. The way OpenClaw, I think, took the world by storm is because it was one of the first projects to really harness the power of the newer reasoning models. I think it was Opus 4.7 around September last year that we all kind of recognized in our coding agents, wow, these agents are so much better at writing code. OpenClaw took that same power and applied it to tasks that a personal assistant might make. OpenClaw also kind of coined this idea that you can have the agent running in the background somewhere and talk to it from different clients. You don't have to go to chatgpt.com or open up Cursor or whatever. You can interact with it from Telegram. You can interact with it from WhatsApp. So now you take this assistant on the go. And this is both really exciting because it can do so many more powerful things that weren't possible before, and it makes it so much more accessible. But it's also kind of terrifying, right? Because now we're giving agents access to our emails, and through our emails they can get access to our banks and so on and so forth. And so you need proper guardrails there. When you're doing like a personal assistant type thing, you get to dial that in, you get to choose your risk level. But what OpenClaw did for the industry, which is quite astounding, is it kind of showed us what's possible. And now a lot of agents want to be equally as capable as OpenClaw, but within sort of more confined guardrails, essentially. And it was on the back of the success of OpenClaw that we ended up shipping a few features to help that, such as workspaces to give your agent a file system, a shell feature to give your agent access to run terminal commands, which means it can generate and run code and do more autonomous things without the need to predefine every tool. So I think it's just an enormous shift, basically, and we're still learning how to ride that wave.
Cool. All right, we have to move on to get the last speaker, but thank you very much, Alex and Tony, for your informative speech talks. Yeah.
Thank you so much.
A round of applause.
Thank you, everyone.
Thank you.